Hello guys, welcome back to lecture series on M3 subject. For more videos, check in my playlist. I uploaded plenty of the videos there. So in my today's video, I'm going to explain to you all one of the important question from SPPU exam, which asked in many more times for finding the general solution. So I already uploaded similar videos in my channel. So if you are interested to see, go and check in my playlist. Okay. So here for finding the general solution of a differential equation, okay, linear differential equation, second order linear differential equation, we are going to find out the general solution here. Okay. So for finding the general solution, as we know that general solution can be written as complementary function plus particular integral. Okay. Yes. Now let's go for finding the complementary function CF. I'm going to write CF as here a complementary function. Okay, in short form CF. Okay. For finding the complementary function, we go for first auxiliary equation. Okay. We go for finding auxiliary equation using our given differential equation. Okay. Now see that d square y, that means we have first term d square minus second term minus 9 times d plus 18. Okay, 18 which is equal to 0. This one is our auxiliary equation as we want the roots. Okay, the roots of our given auxiliary equation. So let's go for finding the roots. So how can we find the root here? So we want the two numbers, their multiplication is 18. Okay, their multiplication is 18 and their addition is a minus 90. Okay, which are the two numbers? Minus 3 and minus 6. Okay, so we want two number, their multiplication is 18. Okay, so minus 3 multiplied by minus 6, so minus minus positive. Okay, 3 6 are 18 and we want their addition, minus 3d minus plus minus 6d. Okay, if you are going to add them, you will get the minus 90. Okay, so replace this one as d square minus 3d minus 6d plus 18 which is equal to 0. Okay, take d common from here, we left here with the value d minus 3. Again what we do, take minus 6 common here, we left here the value with the d minus 3 which is equal to 0. Okay, so we got the d minus 6 and d minus 3 which is equal to 0. So value for d which is a 6 and d which is equal to 3. Now see that we got the two roots. Okay, two roots which are real and distinct, and when we have two roots real and distinct, we write their complementary function c1 e to the power first root m1x plus c2 e to the power 3x. Okay, this one is our required complementary function. Okay, now about telling about the particular integral. Okay, now see here, most of you all are thinking particular integral, it's quite confusing or difficult, but it is not that difficult, guys. It's one of the easy method for finding the particular integral. So if you want, there are some other method that we can deal with the value of a particular integral, like a general method we are using here. Okay, that one is a general method. So other than this, you will get the shortcut method also. Using that shortcut method, you can find out the particular integral. Okay, and again another one more famous method in mathematics, which is a variation of a parameter. Okay, variation of a parameter for finding the particular integral, which is also very much important here. But about variation of parameter and shortcut method we are going to learn it later on. Okay, but right now we are going to find out the particular integral using our given general method. Okay, let's get start our particular integral for finding the pi. Okay, for finding the pi, we are going to find out the pi over here. Okay, yes, for finding the pi, we know that we write pi as a 1 upon f of d into phi of x. Okay, we write 1 upon f of d into phi of x. Okay, so let me write here f of value for f of d which is a d square minus 90 plus 18. Okay, this one is the f of d, but instead of that I'm going to write d minus 6 as into d minus 3. Why? Because we have the result 1 upon d minus a into d plus a. Okay, so you have to convert in one of the form. That's why I'm going to take f of d as a d minus 6 and a d minus 3. Okay, this one is the f of d, and we want phi of x also. Okay, so phi of x, which is here non-zero right hand side. Okay, so take phi of x as e raised to minus 3x. Okay, this one is a phi of x. So we got the phi of x, f of d also, and phi of x also. Okay, so replace both of these value here in our particular integrals. Okay, so we are going to write 1 upon f of d, that means 1 upon d minus 6 and d minus 3 multiplied by phi of x e raised to minus 3x. Okay, this one is a phi of x. Okay, so this one is, we have particular integral, so we are going to remove that d, that means differentiation here from here. Okay, and we'll get the required particular integral. Okay, we know that 1 upon d minus a into phi of x. How can we write 1 upon d minus a into phi of x? Already I explained in my previous lecture. How can we write 1 upon d minus a? Okay, use. Okay, so we are going to use here 1 upon d minus a into phi of x, which is as we have negative term here, so we have to take e raised to ax as a positive term here. So when we have negative a, take positive a here. Multiply phi of x, if it is positive, take it is negative term. Okay, this one is our required 1 upon d minus a phi of x e raised to x, phi of x into e raised to minus x dx. Okay, this one is our required formula. Apply that one here. Okay, so apply that one here, and then we go for finding the solution. Okay, yes, so you can take 1 upon d minus one of the term out here. So I'm going to take 1 upon d minus a out here. Okay, and under bracket he left here with the value 1 upon d minus 3. Okay, so I taken 1 upon d minus a means d minus a means d minus 6. Okay, this one is a d minus 6. 1 upon d minus 6 out here, 1 upon d minus 3 under bracket. Okay, yes, and which multiplied by, okay, what we have multiplied by, okay, is phi of x. Phi of x term it is here, e raised to minus 3x. Okay, e raised to minus 3x. Okay, we are going to find out the integral of this one. Okay, so now see that this 1 upon d minus 6 keep as it is, don't go for anything changes. After getting the solution from this one, we are going to multiply 1 upon d minus 6 to this term. Okay, right now we are not going to change anything here. Okay, so 1 upon d minus 6 keep as it is. So we know that 1 upon d minus a, what is the value for a here? Value for a, don't consider that 6. Now we are considering these two terms. So a which is here 3. Okay, that means a which is equal to not negative 3, minus a which is equal to minus 3, that means a which is equal to 3. So and phi of x, what is the value for phi of x? E raised to minus 3x. Okay, phi of x can be written as e raised to minus 3x. Okay, okay, this one is the value for phi of x. Now replace this value in our given integral. So we are going to write 1 upon d minus 6, it is already outside, and under bracket 1 upon d minus 3 into, that means 1 upon d minus a into phi of x. Okay, e raised to 3x. Okay, this complete bracket, which is equal to e raised to ax. Now what is the value for a? That means e raised to x become e raised to 3x. Okay, and under bracket phi of x, what is the value for phi of x? Replace it here, e raised to minus 3x. Okay, so this one is, let me check phi of x, what is the value for phi of x? It is a negative of 3x. Okay, e raised to minus 3x, this one is negative term. Okay, yes, so I replace that phi of x here, and e raised to minus x, so e raised to minus 3x, as we have a which is equal to 3. Okay, and dx keep as it is. Okay, so we are going to solve this integral, then you will get the value for this entire bracket. Okay, so we'll get the end value for this entire bracket after solving this integral. Okay, so in my previous lecture I explained to you all, whenever you have function to the power function, or function multiplied by function, or function divided by function, go for a substitution method. And what the value we are going to substitute only the highest, okay, power to the power function. So we have e raised to minus 3x, consider it as a t. So if you're going to replace e raised to minus 3x, you have to replace this one, replace also this one, and you need to replace dx also. We are not going to replace that e raised to 3x because it is out of the integral, so it doesn't matter for our solution. We just have to remove this integration. So if you want to replace dx, that means differentiate this one. So how we are going to differentiate? E raised to minus 3x, that means e raised to x has a differentiation, e raised to x itself. Okay, that means e raised to minus 3x has a differentiation, e raised to minus 3x. But later on we are going to differentiate minus 3x. So we are going to write it's a differentiation multiplied by minus 3x. So minus 3 it is coming only. Okay, yes. So we are taking its differentiation. Okay. So e raised to minus 3 into minus 3, okay, which is equal to dt by dx. Okay, dt by dx. So take dx here and a negative here, then we are going to write e raised to minus 3x dx. Okay, e raised to minus 3x dx. Okay, we are going to write this value as a dt by minus 3. Okay, dt by minus 3. So what I have done here, so e raised to minus 3x dx, I replace this value as a e raised dt by, I'm going to replace this value as a dt by minus 3. Okay, replace all this value in our given integral. Okay, so what we are going to get here, okay, so see that e raised to 3x keep as it is. Okay, under integration e raised to minus 3x. Okay, so e raised to minus 3x is a d, so we are going to write e raised to t only, and e raised to minus 3x dx, which is a dt by minus 3. Okay, dt divided by minus 3. That negative, it is a constant here, and it is the multiplicand of e raised to t, so it is not going to affect anything here for our function. So take negative 3 out of the integral. So we are going to write e raised to 3x by minus 3. Okay, integration of e raised to t, it remain e raised to t itself. Okay, and next we are going to replace that value of t. Okay, so revert that t back again here. So e raised to 3x by minus 3, what is the value for t? E raised to minus 3x. Okay, now see that how easy it is to solve. Okay, so e raised to t, we are replacing e raised to minus 3x. Okay, this one is a e raised to t, because e raised to t now, so e as it is here, the value for t e raised to minus 3x. Okay, I replace this value here. So actually this one is the value for, this one is value for this bracket only. Okay, that bracket I solved it here, but this bracket we have multiplicand as 1 upon d minus 6. Okay, 1 upon d minus 6, 1 upon d minus 6, this one is the bracket. So we are going to solve the next step here as a this bracket multiplied by 1 upon d minus 6. Okay, so let's go for solving the next step. So we are going to write next step as a 1 upon d minus 6 multiplied by what the value we left here in our previous term, 1 upon d minus 6, and it which multiplied by e raised to 3x by minus 3, and which multiplied by e raised to minus 3x. Okay, this one is our particular integral left here. Okay, we are going to solve this one further. Okay, we are going to solve this one further. Okay, 1 upon d by, we know that the standard integral form 1 upon d minus a, standard particular integral form, into phi of x can be written as e raised to, as it is negative here, take it is positive, integration of phi of x, as it is positive here, take e raised to negative x dx. Okay, this one is our standard form. So replace the value, what is the value for a, which is a 6 here, and what is the value for phi of x now? This is entire bracket is a phi of x now. Okay, so we are going to write phi of x as e raised to 3x by minus 3 into e raised to minus 3x. Okay, this one is our value for a, and value for phi it is here. Okay, yes, so we are going to replace both of these values here. So we are going to write this one as a d minus 6, 1 upon d minus 6 into phi of x e raised to 3x by minus 3 and e raised to minus 3x. Okay, this one is the value I replace here in our form. Okay, and then under bracket we the value for that particular integral we write e raised to ax. What is the value for a? We write as 6x. Okay, e raised to 6x, integration of phi of x. What is the value for phi of x? E raised to 3x by minus 3. Okay, e raised to 3x by minus 3 into multiplied by e raised to minus 3x. Okay, phi of x, this phi of x I replaced here. Okay, this is the entire phi of x, and which multiplied by this term also, e raised to minus ax. What is the e raised to minus x? E raised to minus 6x dx. Okay, this one is the entire term. So let's go for the next step. So in our next step we are going to solve this one. Take constant term outside here. So e raised to 6x. Okay, that e raised to 6x keep as it is. Negative 3, it is a constant, take it outside. Under integral we left here e raised to 3x and e raised to minus 6x. Whenever base same, add their power. So e raised to 3x minus 6x, we left here with the value e raised to minus 3x. Okay, and remaining value e raised to minus 3x dx. Okay, this one is the value we left here. Okay, so let's go for solving this step. As we have function to the power function, I already explained to you all, when we have function to the power function we go for substitution method. So e raised to minus 3x I'm going to consider as a t, but we have to replace that dx also. So differentiate this one with respect to x. Okay, so e raised to minus 3x differentiation of e raised to minus 3x is the e raised to minus 3x, and again differentiate minus 3x with respect to x, will get the minus 3, which is a dt by dx. Okay, so we want the e raised to minus 3x dx. Okay, so e raised to minus 3x dx, take dx here, e raised to minus 3x dx, which is equal to dt by minus 3. Okay, so I taken dx here, minus 3 to the outside. So replace these values in our given integral, e raised to 6x by minus 3 under integration e raised to minus 3x dx, e raised to minus 3x dx, which is a dt by minus 3, dt by minus 3, and e raised to minus 3x. Okay, e raised to minus 3x means e raised to minus 3x as a d. Okay, take minus 3 constant out here, so minus 3 multiplied by minus 3. That one we are going to write minus 3 multiplied by minus 3, which is a plus 9, e raised to 6x, keep as it is out of the integral. So we are going to write integration of e raised to 2 dt as a e raised to t only. Okay, so replace the value of a t, because we want the solution in the form of a x only. So value of a t we have here e raised to minus 3x. So our required answer, e raised to 6x by 9 multiplied by e raised to minus 3x. Okay, this one is our required particular integral. Okay, now let's go for writing the complete or general solution. Okay, so general solution, we're going to write general solution. Okay, what is the general solution? Is a complementary function plus particular integral. Okay, so as we have, this one is a particular integral. Okay, so this one is important step. This one is a particular integral, and what we got, the complementary function, as earlier we solved complementary function as a c1 e to the power 3x plus c2 e to the power 6x plus complementary function we found here e raised to 6x by 9 e raised to minus 3x. Okay, this one is a completely general solution. Okay, this one is a completely general solution. It is very much important for your example, guys. So I hope you all have understood this solution. Okay, it's one of the easy example asked in so many times in your previous question paper. It's around for 4-5 marks, so don't lose such a easy marks in your exam. Okay, that these examples will give us very easy marks. I hope you all have understood my today's lecture. It's not that difficult, it's very much easier. Okay, if even after you found anything difficult, let me know in my comment section. I will come up with the similar videos. Okay, and in my next lecture I'm going to explain to you all shortcut method. Okay, shortcut method to find out the particular integral. Okay, we are going to find out the shortcut method for particular integral. Okay, that's it for my today's lecture. So thank you everyone, thank you for my today's lecture.